Hey guys, today we're going to be continuing with our characteristics of functions. We're just about to wrap all of this up. So we're going to be looking at continuous versus discrete functions and then increasing and decreasing parts of functions. So to start us off with, we're going to look at a continuous function. So a continuous function is a function whose graph is a smooth, uninterrupted curve. So that's most of what we think of when we're thinking of graphs. So for example, this graph here would be continuous because the curve continues on smoothly. It never breaks or stops. So a discrete function is a collection of individual points. So it's not a connected curve all the way throughout. So for example, this function over here would be discrete because the points are all individual. They're not connected throughout. So a function is either continuous or discrete. Those are opposites of each other when we talk about functions. So we've got some examples. We want to know if these functions are continuous or if they're discrete. So this one, if we look at our curve, there's never any point where our curve breaks apart. It continues all the way along the line. So if I was going to go and trace this with my pen, I could trace it without ever having to pick up my pen. So this function is going to be continuous. Our next one, notice this is several individual points. There's no line connecting all the way throughout. So this function would not be continuous. It would be what we call discrete. All right, so these are pretty easy. Is it a line or is it a bunch of points? Continuous or discrete? We sometimes do have weird ones that are mostly continuous until something strange happens. So for example, this function, there is a single curve that I could trace all the way up here, but then when I get to the top here, all of a sudden the graph picks back up down below it. So that's one of those weird ones where it's mostly continuous. So when we talk about this function, it's not discrete because it's not a bunch of individual points. It's pretty much continuous, so we say it's continuous except at, and then we describe where it's not continuous. So if we think back to when we did domain, with the domain we were looking from left to right. So as we look from left to right, we're looking for where does that graph split apart? Where does it stop connecting? So if we keep going on our graph, right when we get to the center where x equals 0, that's where our graph starts to split up. And that's where it curves up here and then comes up from down here. So because of that, we're going to say it's continuous except at this spot right here where x is equal to 0. So occasionally there are those weird functions that are mostly continuous. There's just one or two spots where it's not. All right, we looked at continuous functions and discrete functions. Next we're going to talk about increasing and decreasing. So we say a function is increasing if, as the x values increase, the y values also increase. So a function's increasing if, as we look at it from left to right, the graph starts to go upwards. That makes it an increasing function. We would say a function is decreasing if, as the x values increase, the y values decrease. So that means if we're looking at the graph of our function from left to right, it's starting to slope downwards. So you can think of it kind of like having a positive slope or a negative slope. We're not going to be looking at just lines though, not just straight lines, so we don't exactly have a single slope like you would with a normal line. And then to help us figure out where a function's increasing and where it's decreasing, because sometimes functions in Algebra 2 can be increasing in some spots and decreasing in other spots, we're going to use interval notation, just like we did when we did the domain. So we use interval notation to describe where functions are increasing and where they're decreasing. And when we use that interval notation, just like with domain, we're talking about the x value, so horizontally, where it's increasing and where it's decreasing. So let's look at an example. we've got this function here. We don't know what this function is. It's a whole bunch of different lines thrown together, but we need to know where is it increasing and where is it decreasing. So I always start on the left and just work my way across the graph. And we want to find the intervals where it's doing something and then it changes. So if I start, and I'm going to do this in different colors so we can see it. If I start on this part of the graph, as I move to the left, my graph is going upwards. So notice as my x values are getting bigger and bigger, my graph is going up, so my y values are getting bigger. So I get to this point before my graph changes. So I'm going to stop there for a second. So I know from this point to here, my graph is increasing. After that, if we look, and I'm not going to write the intervals yet, I'm just going to trace. So here we said it was increasing. After that, we get to this part right here. And in this part here, our y values aren't going up and they're not going down. So at this point, our graph isn't increasing or decreasing, it's constant here. So when we look at increasing and decreasing intervals, we're not going to worry about that section right there. All right, then we get here to whatever this point is, and our graph starts to curve downwards as we go to the right. When we get to this point, and then all of a sudden, if I keep tracing my pen, my hand's going to start to move back up the graph. So I'm going to stop here, and this section is going to be a decreasing section. And then to finish off, from this point, hang on, need a different color. All right, from this point to the end of our graph, my hand continued to move up, so it's continuing to increase. So now we need to go through and find what each of these intervals are that we labeled as increasing and decreasing. So for our first interval for increasing, we're looking at the x coordinates. We're not worried about what the y value is. So our first point is right here, and the x coordinate of this, if we count back, -5, -6, -7, -8, -9. So I'm going to write that in. So that's going to be the first part of our interval. Then we stopped here, and if we look for the x value, that x value is -5. So from -9 to -5, we were increasing. So when we write our interval, we include the lower bound for when we were increasing and then the upper bound. And we always put parentheses around this. When we talked about domain, sometimes we had a square bracket for something that was included. But when we're talking about something increasing, things can only be increasing over a period of time or a period of distance. If I have just a single point, if I just put a point on the graph, I can't say that this point is increasing or this point is decreasing. It's just one point. So because of that, we don't include the -9. We say from -9 to -5, it was increasing, and we put parentheses around it. All right, and then we had one other section for increasing. That section started right here and went to this point here, so we need to know the x coordinate here. So this is right in the middle of our graph at the underneath the origin. So if we want to know the x coordinate, we want to know how far left or right we moved from the origin. Since we didn't move from the y-axis, that means our x coordinate is 0. So our other interval is going to start at 0, and then we need the x coordinate for this point. So if we look over, that point is that here, I think? So 1, 2, 3 over. So our other x coordinate for the increasing interval is going to be 3. All right, and then we need to determine where our function was decreasing. So our function started decreasing right here we're 2 over, so at -2. And then it continued decreasing till we got to this point, which we already said was 0. So from -2 to 0, we were decreasing. So the big important thing here when we talk about increasing and decreasing functions is that your function, when you write let me say that again. When we talk about increasing and decreasing functions, when you write the interval, you are writing the x values that is increasing or decreasing on. We're not worried about the y values. So when you're writing this increasing interval, you don't need to know how low and how high it was. You need to know how far to the left and to the right that increasing period went, or how far left and right did it go while it was decreasing. So those are the interval values that you're writing, not the y coordinates, you're writing the x coordinates. All right, we've got one more to look at here. So this one, if we start on the left, if I start to trace my graph, as I trace down my graph, the whole time I was decreasing, the whole time it was sloped downwards. So as the x values got bigger, the y values here were getting smaller. And notice for this graph, my graph actually goes off the edge of what we can see. So when we talk about where this was decreasing, as far as we know, it was decreasing forever and ever and ever. It came from way back here and came down this direction. So because of that, when we talk about the decreasing interval, we're going to say we started back at negative infinity. So it started decreasing all the way back at negative infinity, and then it comes down to this point right here, which is negative 5. So from negative infinity to negative 5, we are decreasing. All right, next, as we continue along our graph, our y values are starting to get bigger. Our graph is sloping upwards as we move to the right. So because of that, this portion right here is increasing. All right, so through here, we're going to be increasing. And so we know where that interval starts because it's where the other one left off. So we're starting at negative 5, and then we go until we get to this point right here. So if we look, we are 1, 2, 3 over from the middle, from the y-axis. So that x coordinate is going to be negative 3. So that's where we're increasing. All right, next, as we continue to move to the right, our graph doesn't move up or down any. Our y value stays the same. So for this middle part here, we're not increasing or decreasing. We're staying constant. So we don't include that when we ask for increasing and decreasing. And then finally, our graph starts to change right here, and it starts to slope downward again. So as our x values are getting bigger, our y values are starting to decrease. So that starts at this point right here, which is 1, 2, 3 over from the y-axis to the right. So that starts at positive 3 for our x coordinate. And then as it slopes down, it keeps going off the edge of our screen. So because of that, it's decreasing infinitely. So our interval is going to end at positive infinity. All right, you guys, that is it for continuous and discrete functions and also increasing and decreasing functions. Let me know if you guys have any questions about this, and have a great day.